Hello everyone, welcome back. In this video, we're going to begin our discussion on solving systems of linear equations. And to get that discussion started, we're going to review how to solve small systems of linear equations involving two equations and two variables. And so here we have an example of such a system. The first equation in our system is 2x plus 3y equals 7. And the second equation in our system is x minus y equals 1. And so here we have two equations and two unknowns. We'll often refer to this as a 2x2 system of equations. And our goal by the end of all this is to know how to solve larger systems of equations like 3x3 systems or 4x4 or even larger than that. Although our primary focus is going to end up being on 3x3 systems of linear equations. That is, we're going to have three linear equations with three variables. But before we figure out how to handle the 3x3 case, I want to review the 2x2 case. And so remember, for a 2x2 system of equations, a solution is going to be an ordered pair, x comma y, right? An x and a y value. And what's got to be special about that x and y value is that x and y value has to satisfy or solve each equation in our system. And so we're actually going to go ahead and solve this system algebraically using like the substitution or elimination methods. But first, I want to review the geometry, what is going on in the picture behind the scenes here. We know that if we were to graph these equations individually, each equation would give us a line. So maybe for this system, this first equation gives us a line that looks something like this. These pictures I'm drawing are not supposed to be accurate at all, just a visual aid. And maybe the second equation gives us a different line. Maybe that one looks something like that. And so every point on our line, every ordered pair x comma y is an ordered pair that satisfies that individual equation. And graphing all those ordered pairs together gives us the line corresponding to each equation. And so when we're trying to solve a system of linear equations, we're looking for that ordered pair that satisfies both equations, that is, that ordered pair or point that is on both of our lines. Well, if we start to think about the picture of that situation, what is the point that is on both of our lines? Well, that is actually the point where our lines intersect. So the solutions to our 2x2 systems of linear equations are going to correspond to points of intersection between the lines inside of our system. And so on our first graph up here, we kind of have the best case scenario where our lines intersect and we get one solution. Maybe the first equation in our system has a graph that looks like this, and the second equation or line in our system looks like this. Well, in this case, our lines are parallel, and parallel lines never intersect. And so we would have no solutions in a system of equations involving parallel lines. And so the two scenarios that we've seen or discussed so far are we could have one solution, that is where our lines intersect. We could have no solutions, that's where our lines never intersect, and that corresponds to the lines being parallel. And our final situation is maybe our first line looks like this in blue, and the second line in our system generates a line that lands right on top of that first line. So in this case, we have more than one point of intersection. Every point on either line satisfies both equations, and so here we would have infinitely many solutions. And so we got to be a little bit careful when we say infinitely many solutions. Infinitely many solutions does not mean that any pair will work, any solution will work, but it does mean that there are infinitely many solutions in the sense that we can always find more and more special ordered pairs that will satisfy our system of equations. And so that third scenario, when we have infinitely many solutions, only is going to happen when our lines land on top of each other, and that is when our lines, we say, coincide. All right, so now let's go ahead and solve our first example here of a 2x2 system of linear equations. And there's two algebraic methods that you've probably seen before that help us solve such a system. And those are the substitution method and the elimination method. So when we are applying the substitution method, the process is we are going to look at our two or more equations involved in our system, and we're going to solve one of the equations for one of those variables in terms of the other. And so that means we have to look at our first or our second equation here and make a decision on which variable we want to isolate And to help us make that decision, we just kind of look at it and think about which one can we solve for with the least amount of effort. And so if I'm going through that process here in this example, I would focus on equation 2 and notice that I could solve it for x or y pretty easily and pretty quickly. And so let's go ahead and label that first equation, equation 1, and that second equation, equation 2, just to make my referencing a little bit easier to follow. So the first step in the substitution method that I'm going to take is to solve equation 2 for one of our variables. And I'm going to go ahead and solve for x. And I can do that just by adding y to each side. So from the second equation, we know that for the system, x is always equal to or equivalent to 1 plus y. And so what that means is that we can now make a substitution using that second equation and the first equation to make a new equation that is only in terms of one of our two unknown variables, right? If we go to our first equation that says 2x plus 3y is equal to 7, and we use in that equation the fact that for our system, x is always the same as 1 plus y, we can make our substitution and eliminate the variable of x, right? So now our first equation says 2 times x, or 1 plus y, plus 3y is equal to 7. By performing the substitution step, we've reduced one of the variables in our system, and now we're left with an equation involving only one variable, and now we can solve for that unknown variable. In this case, it's going to be y. So to solve this, first we should expand, get 2 plus 2y plus 3y is equal to 7. And now we need to combine like terms, move some stuff around. Looks like we have 5y's on the left-hand side. If we then subtract that constant of 2 from each side of our equation, we get 5y is equal to 5. Dividing both sides by 5 tells us that y is equal to 1. And now we're not done solving our system of equations until we found both our x and our y value. And so now that we know y, we can use that information to help us go back and find x using that alternative form of our second equation that says x is just 1 more than y. So just plugging our y value of 1 into 1 plus 1 lets us know that x is equal to 2. And so our single solution to this 2x2 system of linear equations is the point or the ordered pair 2, 1, right? We always write x first and then y, so don't forget that, even though we solve for y first. So xy is 2, 1. That is our single solution here. We're in that first case. All right, everyone. So we just ran through this example using the substitution method to solve our system of linear equations. And we found our solution was the ordered pair 2, 1. And so now I also want to review the elimination technique for solving such a system of linear equations. So when we found our solution the first time using the substitution method, that process was taking one of our equations, solving it for one of our variables, plugging that expression into our other equation, and then solving for the remaining variable. The elimination method is slightly different, but it's going to accomplish the same task. With the elimination method, we're going to take some combination of our equations, add or subtract some multiples of our equations together in such a way that one of our variables gets eliminated and we end up with a new equation involving only one variable. And then from there, the steps are exactly the same as what we used in the substitution method. We'll solve that remaining equation, find the value for one of our variables, then back substitute to find the value of the remaining variable. So when we're setting ourselves up for the elimination method, we have to kind of decide how do we want to combine our two equations together. We want to add or subtract some combination of equation 1 or 2 here in such a way that either x or y gets eliminated. And it really doesn't matter which one you choose to eliminate here. Sometimes it just depends on the coefficients or the numbers involved. And so here I might notice that, well, the y's already have coefficients that are opposite in sign. The first one is 3y, positive 3y. The second one is negative y or negative 1y. And so if we want to combine these equations together so that y gets eliminated, one way to do that is to multiply the second equation and everything in it by 3 and then add the equations together. This is not the only way to eliminate the variable y. We could also divide the first equation by 3 and then add the equations together, but I think that'll involve more fractions and complicate the process, although it doesn't matter because in the end you should get the same solution either way. And so the choice I made to help us eliminate y, right, we could make different choices if we wanted to eliminate x, but the choice I'm going with is I'm going to take equation 1 and add to it 3 times equation 2. That's what my notation over here is trying to describe. So I'll go ahead and rewrite equation 1 just as it is. 2x plus 3y is equal to 7. And then below that, I'll write 3 times our second equation. So I have to multiply both sides or every term in our second equation by 3. So we'll get 3x minus 3y is equal to 3 as our second equation multiplied by 3. And now we are ready to add our 2 equations together, which we can just do side by side. So add the left-hand side to the left-hand side and the right-hand side to the right-hand side for each equation, and then combine like terms as we do so. So 2x plus 3x gives us 5x. Positive 3y plus negative 3y eliminates that term altogether. That's why we call this the elimination method. And it eliminates the variable of y from this leftover equation. And so now we have to add the right-hand sides together. 7 plus 3 is 10, leaving us with an equation in one variable of x. 5x is equal to 10. Now we can divide both sides by 5. And we find, once again, that x is equal to 2. And to finish this off, we need to back substitute and solve for y. So we don't have a nice equation for y in terms of x like we might have if we use the substitution method, but we can still find y pretty quickly using equation 2. Right, plugging in x equals 2 into our second equation gives us 2 minus y is equal to 1. Or 2 is equal to 1 plus y. Or y is equal to 1. You can solve that however you want. Those are just the steps I decided to take. But either way, we cut it using either the substitution method or the elimination method. We find the exact same solution to our 2 by 2 system here. That is the ordered pair 2, 1.